morning, everyone. It's actually interesting to note first that in 2023, a survey by MIT found that 83% of ML professionals consider identifying bias as a top challenge, underscoring the complexities involved in detecting and addressing biases within the AI models. For us, it's obvious. It's actually hard to say when we use complex models why the model makes the decision that it does. But on the other hand, AI systems are increasingly shaping our decisions in areas like hiring, medicine, lending, or even law enforcement. So while the potential to improve efficiency and fairness is immense, they also risk amplifying society bias if not carefully designed and monitored. So this is where explainable AI comes into play. By making AI systems more transparent, we aim to demystify how decisions are made and identify areas where bias might be creeping in without us seeing. But the big question is, can explainability alone tackle the complex web of biases inherent in our AI systems? So we have great experts here today with us to help us understand explainability better and how bias comes into play within the topic. First, we have Kseniia Fontaine, a Senior Business Development and Operations Manager at ITU, the United Nations Specialized Agency for Digital Technology, as a key member of AI for Good team, connecting AI innovators, problem owners to collectively advance the United Nations SDGs. Congratulations.
Thank you. Thank you. Pleasure being here.
We have Wojciech Samek, professor at the Technical University of Berlin, head of the Department of Artificial Intelligence at the Fraunhofer I'm sorry, my German's bad. Hertz Institute, HHI, in Berlin. His research focuses on machine learning and neural networks with a strong accent on explainable AI, especially in image recognition. Welcome. We have David Roberts, Chief Technology and Product Officer at Allegro, where he leads all of the company's technology teams, where he focuses on strategy, vision, product development. Prior to joining Allegro, he spent over 4 years in Germany building and scaling Zalando's partner program across Europe, and in Amazon, where he says he earned his PhD in product and technology development. Welcome. And last but not least, Biecek, professor at both Warsaw University of Technology and University of Warsaw. His research focuses on explainable artificial intelligence, predictive modeling, data visualization, and model interpretability. He leads the MI² group, a team of experts developing tools and methods for responsible machine learning. Welcome. So, to start off with a simple question, as we're dealing with a very hard topic, Przemek, I wanted to ask you, why is explainable AI important, and why are we focusing on it today? Maybe you can briefly touch on the distinction. Why are some models maybe harder to explain? Why are some easier? And for those of us who may not be familiar with these concepts.
Yeah, awesome. Very important question. So I have like 50 minutes or something. Yeah. So there are two questions. So let me attack them separately. Like one, why XI is important, and we can imagine that there are different phases of maturity for AI. So with these different phases, there will be different challenges for explainability. So currently, we're kind of on the beginning, early AI, let's say, and still these systems are doing a lot of mistakes that are not working properly. So we can use explainability actually to avoid these mistakes, to have a better control. So you can imagine things like discrimination, models discriminate different genders, age groups, and so on. So with explainability, you can actually tackle these problems. So we can create better models with lower number of mistakes. Also, hate speech, misinformation, these problems can be controlled. So we can use explainability to control these systems to have them more aligned with our expectations. But then, after we'll solve these problems, after we'll get models that are not doing mistakes, what then? It's not like XI will stop. Actually, for the advanced AI, I guess that there is a lot of new challenges that we can use. It's kind of gaining new knowledge. So we can use explainability to extract some knowledge from models with superhuman performance. And in some areas, like protein folding or playing chess, we already have models that are doing better than human. So with tools like explainability, we can extract this knowledge to actually create better basis for our future development. So there is plenty of reasons why we should work more on XI. And the second question was about the explainability, interpretability trade-off. So there are many different approaches, ways how we can group these different techniques. There is a lot of different techniques. One is to think about models that are easy to explain, like linear regression rules. And second is about to think about models that are very, very complex. But actually, I like a different division. Division that is kind of separating these techniques between the blue sky and the red sky. What does it mean? Like explainability, blue sky explainability is focused on humans. Like, trust, trust, what I have here, so let's see. The problem with trust is that there are some users that do not trust models and models are not used, but also there are some users that trust too much. And if models are not working correctly, over-reliance is a problem. So, the blue sky is kind of understanding the user, the customer, how the customer will interact with the model. But again, I'm more a researcher and I'm interested in the red sky. So these are tools to extract some knowledge from models, to learn why these models fold proteins better than other solutions, why these models play chess better than human. If there will be new models that play economy, for example, the question might be why these models are playing economy better than humans. So there are kind of different groupings, how we can see these opportunities for explainability.
So a social element, sort of. The blue sky is a social element of how we interact with
like value-oriented versus validation-oriented.
Yeah. And taking this into account, according to McKinsey, by 2024, 72% of organizations had already integrated AI into at least one business function, which is a very, very big number. So many of these implementations rely on neural nets, so harder models that need more explanation, as Przemek has pointed out, that need more time for the red teaming of these models, the red XI. So I wanted to ask you, Kseniia, how does this tie into the issue of bias? How do you see explainability? Is this an effective approach to address the bias? And additionally, are there standards or regulations in place that require models to be explainable?
Yeah, thank you. Well, there are a couple of questions. So maybe I would question a bit the McKinsey statistics. Do we talk about the adoption of this AI in developing world or in developed? So I think that's the question that we look into a lot at ITU. So, when AI for Good was created in 2017, AI technology was available to maybe a few groups of people. Now we can see that it's entering the mainstream. But actually, what we see, how can we make sure that those models, even explainable models, can work well on women with different skin colors, on men, on women, on children, on people with abilities. And quite often in the industry, the fast-paced industry adapts the approach. We build it now, we fix it later, right? And then all the solutions, they're coming from Silicon Valley, maybe to Africa region. So at ITU, at AI for Good, we actually think deeply about those questions, how those models can work, but also how they can be developed with the local settings. And one of the big questions regarding the bias is not about the explainable models, but actually about the data. Who labels the data and who builds those models? So in December, I went to AWS reInvent. It's one of the biggest developers conference in the world. And what struck me that I think it's like 40,000 developers coming there. Most of them were men, white, in their early 30s. So I was thinking about it, like, okay, if these are the people building those AI models, and of course they have probably some biases, some approach about the life, how they see things. If those are people building those models, how can we actually ensure the AI models are not biased? And then the second question to the regulations. So at ITU, we have actually right now over 220 AI standards being in development or published, and lots of them are focused on trustworthy AI applications. So this is like one of our objectives, to identify trustworthy AI applications for sustainable development. So from our perspective, having this global framework, even though it's not maybe adapted in different countries because they have local jurisdictions, is very important because it helps to guide the process of adapting the trustworthy models of AI. But of course, that would be up to each member state to choose the pathway.
Yeah, I think it's very important what you're saying on the perspective of the lifelong caring about bias and about the ethics of the model. So explainability, of course, is very important, and we see it at the sort of lifelong journey of the model itself. But before the model, we have the data, we have the collection, we have the labeling, and this is also the place where our approach to ethics need to be prioritized. But I want to ask you, David, right now. So at Allegro, taking into account this bias and everything that we need to do to ensure the models are safe, so how do you address these challenges? And could you maybe describe your MLOps pipeline on what do you prioritize on this journey of the model, and so that you're sure that the customers are treated fairly, but you're still delivering exceptional user experience?
Yeah. So first, I think most people here probably aren't aware of Allegro, so I should probably just quickly say, so Allegro, we're in Central Eastern Europe. So right now we're in Poland, based out of Poland, and we're in 3 different countries as well. So we just celebrated 25 years, in case people are wondering, and we have, just to give you an idea of the scale, we have a couple 100 million offers. We have 146,000 merchants on the platform. So when we look at scale, it's huge, right? And I've personally been in Allegro for 3 years. So I'm not Polish, but I'm heavily Polish biased now with Allegro. So, and I should also mention, by the way, I don't have a PhD, but we like to just say, sorry, it was just kind of a joke that at Amazon you learn so much. But okay, so now to the question. All right, so what do? So with this, give you an idea of the scale that we have. It's really important for me, and I think you heard also a minute ago about trust. So so absolutely we implement AI in Allegro, but because I'm dealing with merchants and customers, trust is the most important piece. So if I don't have trust, no one's going to use this, right? So how do I build this trust? Well, I have this MLOps. Right, this is part of it. And similar for those that are in software development, which is my background, it's kind of like DevOps, except for instead of starting with code, you start with data. So we start with data. We have heavy process, and I'll give some statistics here in a few minutes on how much we deal with the data. But what we do is we focus on data annotation. So we have guidelines for both internal and also external vendors on exactly what is how do we label this data, and then we have, of course, a validation process. We look in this validation process, we're constantly looking for biases, and then we curate this against humans as well. So we have human data sets that we take this and then we verify. And of course, I'm skipping a few steps here just for sake of time. But in our MLOps pipeline, data is the most important. Then we look at again validation steps, annotation steps, and then we cycle it through, right? And then now one of the problems that we're also facing is with Gen AI, people can create models super fast, right? But the problem is, while you can create this super fast, this validation step becomes much more difficult. Because we don't have all the mechanisms in place, or it becomes much more complex, and then we have to quickly go through and make sure we understand how did this model get set up, where would the data come from, these type of things. So we have this in. Now, one thing else I should mention is I have a core MLOps process, but I also have a very distributed team, right? So I have around 3,000 tech people, and we're building products. And we're building lots of products, and we're trying to use AI everywhere that we can. But I still, across all of these groups, we use this mechanism. Now, with that, we also have to have explainability. So, for example, with explainability, what happens is, let me give you a real-world example. So a merchant comes and they say, David, well, not David, Allegro, we don't understand why in your search model I'm not in the top rankings. Why am I in the lower rankings, right? So if I don't have a way to explain to them, then what will happen is now they'll go to government officials. They'll say, hey, Allegro is unfair. They're biased. Maybe in this case, it's a merchant who maybe is new to Allegro, and then there's some kind of bias. And so what I have to do is I have to have a very well-developed explainability model. So what I do here from a scale perspective is I tightly couple with my microservices explainability and how this works, or my serving my models. So how this works is I'm logging everything that I can now quickly go back and recreate the history. And so I have many cases where this comes up. And so this is one part, so the explainability part. All right, now on bias, again, as I mentioned, it's not just the MLOps part, but really we're also looking at, as we move more and more into neural networks, which I think you'll probably hear more about. By the way, I should also preface this with, I'm not an AI expert. I'm just the person who actually takes these technologies and implements at scale to make our customers happy and our merchants happy, right? So this is also important. So I'm looking at all of the real day-to-day how to make this work. Okay, so quickly, just I told you I'd give you some statistics because I think my clock is running here, which I think might be interesting for you. Let's see. Hold on. Okay, so I have one of my units. It's my fintech unit, Allegro Pay, and in here we use heavy, of course, AI. But I'd like to give you just some quick information. So I can improve a credit rating in less than 7 seconds now, right? From an explainability point of view, 40% of our time is devoted from a technology resource point of view towards explainability models, right? And it's going to get even more difficult and complex as we move more and more towards more black box neural networks, right? So then I've created in the last 3 years over 1,000 models, and of those 1,000, only 100 were deployed to production. So this should give you an idea of how we're really it's not this magic. I create a model and everything works, so it's not magic. Okay, next, every day, because I have over 2 million customers in Allegro Pay, so it's our fintech piece. I process 5.5 terabytes of data. Okay, this is what we're looking at, and this roughly cost me about $150 US. Just for those that, for me, budget is super important. All right, and then when I look at historical risk models, we calculate about 1.2 billion daily versions of customer data points. So anyhow, that just kind of gives you a rough idea. And for each customer, we're looking at around 20,000 variables for that customer. So I thought I'd give you an idea. This is where, again, I'm probably going a little over time. My apologies. Where from a customer merchant point of view, AI is extremely important for us. I have to build trust, and I have to be able to explain. So if there's no trust, no one's coming. No one's going to use these products. So it's important.
Especially in the financial perspective, when people's finances are on the line, especially like healthcare as well. These are very important pieces of economy where we actually have to take care of these biases first and foremost. So as your business, David, and many businesses are going to invest in explainability, and we might say that this is going to be a big thing now, but is probably going to be an even bigger thing in the future. Wojciech, maybe you can give us some insights into your current work on explainability so that we know what to look for in those future trends and what are the emerging hot topics and frontiers of research in the area of explainability.
Yeah, I'm happy to do that. But before that, I would like to go back to this question of bias, because I think I'm not fully agree with what has been said before. I don't think that's a source of bias. The main source of bias are the developers. I think it's more the data which we use for training these models.
Yes.
And unfortunately, we don't have the right tools to analyze the data, to ensure data quality. And I think explainability here can help us in this respect. So I've been working in the field of explainable AI for the last decade. For over 1 decade, we have developed methods which tell us the reasons for a model's decision, so we can explain for example, which pixels in an image were mainly responsible for the classification decision. And we saw that some of these decisions made by the model, even made by models which were trained by big companies, which were used in research, are biased. They were classifying women by the fact that there is a long hair in the image. They were classifying male by the fact that they wear a tie or a collar. And even worse, we saw examples where models learned to classify horses by the fact that there is a copyright tag in the image, because many of the data used to training for training had a copyright tag in horse images. And explainability kind of allows us to detect these kind of sources of bias. But I think where we need to go and what we are currently working on goes even beyond that. So we need more insight. We need not only understand the reasons for a decision in terms of the input features, but we also need to understand step by step the inference process. We need to understand what is going on internally in the model. So I always like to compare it to an airplane. When we build an airplane, we understand the function and the quality of every component. We know that every screw has to fulfill certain quality criteria. We know that the wings had a certain function in the airplane. And with AI, we don't have it so far. So we are building these large architectures, training them with a lot of data, but don't really have a clue what functions individual components have, how they what role they play in the decision process. And this is where we are currently working on. We published a paper recently with a method called semantic lens, where we get this understanding. We can kind of systematically explain the functional role of every component of the model and also how it contributes to the prediction process. So we see kind of how internal knowledge in the model is built up. And on top of that, we can also relate this to the training data. We can see where in the training data this information is coming from, if we have access to the training data. And I think this additional insight can be very helpful for a large-scale analysis of our training data, for a large-scale analysis for bias, so that we can kind of ensure that the data we use to train the models, the knowledge which is kind of learned internally by the model, adheres to our requirements and to our expectations.
Agree.
And I love the analogy. Imagine that you're flying an airplane and you look into the engine and it's just a blob of things that you don't understand. I mean, for most of us, it's true. We don't understand airplane engines, but there are people who do. Yeah. And the difference here is like, who is the person right now who gets it? It's either the explainability expert or nobody at all. So I think also it shows us how early in the stage of the research we are, as we can understand a lot of the explainability and the research that your Wojciech are focusing on. There's still a lot of these, let's say, operations that we need to do. Reminds me of, I think in the Renaissance times, it was said that humans are just filled with blood because wherever you pinch them, they bleed. And the idea that there are veins and there are things that actually move the blood was not so well understood. And this is a place where we are with AI. So maybe, Przemek, you can talk more about your work on explainability and maybe give further context on why explainability should be a priority, not only for researchers, but for CTOs like David and organizations that actually want to get something with the explainability.
Sure. I guess that there is a clear added value that can be extracted with the use of Xi tools. And maybe to have some analogy to revolution that already happened, the data science revolution, it was kind of very huge interest in new concepts, new information that can be extracted from data itself. So I think that after the AI hype that is hopefully finishing, then the new hype will be on model science. So same things that happened with the data science now will come up with model science. So models will open new ways to do new things, like extract new knowledge. Knowledge that can be used to create better antibiotics, knowledge that can be used to create better proteins, knowledge that can be used to better understand our customers, to maybe help them to take better decisions. So model science, it might be about tools like software tools, how to create, how to control, how to analyze these models. It might be more about procedures, like how we should interact with a model actually to better understand the model behavior. So still, we are on the beginning on this path, and we are looking for good success stories that can be then shared. So I have two that I would like to share with you. One is related with European Space Agency that is going to use more and more AI models in space for space operations. And then again, the nice information about the space agency is that experts is working there. If you think about space engineers, there are people that have really deep knowledge about physics, about operations of these satellites. So if you are going to add some additional models that should be used in space, they cannot be black box models because these guys, these operators, they spend years on learning the physics of the satellites. So they would like to have a good understanding of AI models that will be sent there to make sure that they are working aligned with the human value. And the second use case that I'd like to share with you is related with the medicine, healthcare. Again, with the healthcare, you may think about different levels of explainability. The first one is that, oh, we have an image, where is the cancer? Here is the cancer. So we are currently on this level in which, on pixel level, we may say this pixel contribute to the prediction. But for radiologists, for physicians, actually, it's not that useful information because the decision that they are facing is what to do with this information. It's not that hard to spot a cancer. It's much harder to decide what will happen. And now we can use information about the model behavior to better predict the future outcomes for patients. So I guess that we will be collecting more and more success stories like that, and they will open new opportunities for using SAI in different areas.
I think it's really good in the perspective of knowledge extraction because thanks to explainability, AI can not only be used by us, but can actually make us better at our jobs and what we're doing. And I think this is a very good perspective on this. But as you're saying, it has a real market value. So I'm thinking, David, so there's a lot of discussion going on right now about European competitiveness and the vision of Europe becoming a global AI leader, the AI continent. So, however, recent statistics show that America and China are significantly ahead, so investing 62.5 billion and 7.3 billion respectively in AI in 2023. So, with this context, how do you view explainable AI? Can it help Europe gain a competitive edge, or is it just another burden for business leaders?
Okay, so if I put this question down into a little bit more simplistic form for myself, will regulation help me to accelerate my business? No. Okay, simple answer. Now, sorry, but do I think explainable AI is important? I think I just showed you that yes, it is. So what's the solution? Well, from a business point of view, what I need is a lightweight regulation in a sense. I need the explainability or the AI Act to be pretty lightweight. The heavier it is, the more time it takes me, the less performance boost, the less us as Europeans are players in the market, to be honest. So what would I want? Well, if I look at most of the lower end of the AI Act, that's really where 80 to 90% of the models being created and the AI happening here. So let's make that super lightweight. The other thing that I need is really from a competitive version is us in Europe. We're saying, let's create this regulation, it's super important, but the rest of the world isn't. And so what I'm worried is that we're building this massive regulation infrastructure that now is going to penalize us. Sorry, I'm being American point of view in Europe, but what happens is it stops our creativeness. It stops our innovation because now, again, as you saw, I spend 40% of my time already trying to do explainability. And as I mentioned, as we go towards neural networks, now what's going to happen, right? I mean, I'm moving into this space, I'm building all of this explainability, and at some point, Again, I'm not the expert. The experts are on the panel here. But black box, what happens is we're going to get to the point where AI is like the human brain more, and I can ask all of you simple questions. What's 2 + 2? You'll say 4. I'm like, oh, great, it works. But really, I don't know what the inner workings of your brain was to, if you read Socrates and I read it, are we going to have the same endpoint, right? So we're heading that direction. Okay, now I went a little bit science fiction. I didn't mean to, but for me personally, what I'm building, what's the next generation? AI agents, right? So am I going to be heavily penalized in some of these areas where it may not be as completely explainable? This becomes a problem. All right, now what do we do? So it's my belief, again, how do I say, the level of talent that I've met in Europe is incredible. It's off the charts. And we have an ability, in my opinion, an opportunity to get into this game. So instead of having United States and China, and then you've probably all seen the graph where Europe is all about what the best thing to bring to the market is regulation. No, but what Europe has, we have brains, the most intelligent people, in my opinion, and also we care. So Europe cares about people. We can put these pieces together, and we can become the leaders of setting the global standard of regulation. Make it lightweight, make it global, almost like a treaty, in a sense. You think of hopefully I don't get in trouble for saying this. There's nuclear arms treaties. Maybe there should be an AI treaty across the board, because I need a level playing field. From a competitive point of view, I have competitors who have no rules. They have 3 billion people in the population for a data set. They don't, again, they come in from a company perspective, and they compete against me, who I have heavy rules, and I want to be a good citizen and be a good business owner. But they're using European data. All of you who use the apps, your data is being tracked, and this will helps them. And again, it's an unfair playing field. So I really need us to have a fair playing field, which is why I talk about this treaty or across the board fairness or regulation. But I think as Europeans, we have this opportunity to really get in the game, step up. In fact, I would actually even say, if I'm going to really innovate in Europe, we really need to invest. We have to invest. We have to, again, I'm not a tax person or anything like this, but really we need to look at how do we help the businesses. Also, how do we protect some of our businesses? Oftentimes what happens is a company, like I've seen this a couple times in Poland, they start becoming really good, and here comes a global company, and boom, they're gone. So also, I think, I know this sounds crazy because I'm an American. I'm saying we need to do some protection as well.
Protecting local market is a regulation.
Yes. But keep it light. Yes.
Can I add to some of these points, especially what was said by Przemek earlier? I think we need also the right type of explanation. I don't think that having like just an explanation on paper and having like a tick mark and say, okay, we now fulfill this regulation is very helpful. It's just additional burden. We need helpful explanations. And I have been working for quite some time on the problem of benchmarking, auditing models. So really understanding what they have learned and whether this is kind of coherent with what we want. And we recently trained a model on dermatology, image skin cancer detection. And if you have been to a dermatologist, you know that there is this ABCDE rule, that dermatologist looks if the navi is kind of asymmetric, it has kind of border or not, if it's coherent, and so on. So there are these kind of rules of thumb which medical people came up with, which is kind of textbook knowledge. And we recently, with semantic lens, with our recent method, we are able to check whether the strategy, the internal knowledge implemented with AI is kind of coherent with this prior requirements. And I think we need this type of explainability which helps us to understand and give us positive feedback and additional information on our models, and not having explainability which is just which you just tick and which is just a burden for people to do.
Yep, agree.
So sort of translation of this one knowledge, the perspective of an expert, to an actual model, and verifying if the model is following, for
I
example.
mean, this is just like one example from
Of
my
course.
work, which I'm interested in. There could be other domains where other types of explanations are helpful, maybe for other people, or in other applications there could be other type of explainability. Also, for instance, we are interested in understanding hallucinations in LLMs. So if you understand how internal model knowledge is kind of processed, what's happening under the hood, you may potentially better understand why LLMs hallucinate. And this can be helpful in some applications, I think.
And I think explainability is sort of unique in this perspective that if we get this right, of course, it's a very long research journey. If we get this right, a lot of regulation might be lessened off because the regulation on why explainability is needed, because we need to understand. The more we understand, the less we need to regulate. So, or let's say these are those two things that I would say your research, and thanks for doing it, is actually connected to driving this innovation, I hope, in the European perspective. And Kseniia, so in this world of regulation, innovation, investment, I wanted to ask you if you think if we're on the right track on ensuring AI development is used for good. And is it really that the explainability is enough for bias? Or what further steps do we globally need to take to ensure that AI serves us instead of the other way around?
Yeah, definitely. So maybe the first part I will take on the discussion regarding the regulations. The good news that there is a kind of a global agreement that we need regulations, not to diminish innovation, but really to give this global framework. So what we did at last year at the AI for Good Global Summit, we actually launched the first Global AI Governance Day. And this is really to bring all the member states together and identifying like what's in common between EU AI Act, Hiroshima process, Chinese or US regulational frameworks. And actually what we found out that they have more in common than in difference. And this is talking about transparency AI, talking about need for ethical AI. And so then it's all great on paper, but actually how do we move from these big principles into the implementation? So standards, again, is one of the tools to actually implement those regulations. And again, this is not to stop innovation, this is not to develop better applications, but it also gives the chance, for example, again, to the rest, another part of the world, those who don't have access to this technology, to actually benefit from it. Because through international standards, they could use it to improve the economy, so using those big frameworks. So there are lots of discussions that will continue on that front. But then regarding how AI is benefiting us, the humanity for good, well, there was a study that was published in Nature, I think a long time ago, actually mapping how AI applications can advance the United Nations Sustainable Development Goals. And actually it shows that AI can positively benefit 194 or 9 targets across all SDGs. Which is very, very positive, like mapping poverty from space, identifying skin cancer. I mean, we have experts here who could give you numbers of those applications. But then that also showed that actually AI can impact negatively 59 of those targets across all SDGs. First of all, we are in 2025. We know that we are not on track with SDGs, even without AI, right? So there are big issues in education, in gender, in climate, even without use of technology. So we are really behind. So now the question is how actually AI can help us to accelerate the advancement, at least in certain areas. And we've seen the progress in health, in education, but there are some other areas that we are still behind. And I have actually a question to the experts, coming back to the discussion on biases and data. We talk about generating data when we have the access to the internet, right? You track data from a European region where we get access to the applications. What about the communities who actually don't have access to the internet? We have 2.6 billion people who remain offline. This is the ITU statistic. So it's actually it's 1/3 of the global population, so they don't generate data. So in this case, if they don't do this, how can we ensure that they one day maybe would benefit from AI, or those explainable AI models would be properly trained? Is there a solution for this type of, is there like synthetic data or something that can be done? And because most of those populations, again, are coming from Big South, and they have different issues that we face in Europe or in US or other regions.
Yeah, maybe I can comment on that. I think this problem has been also identified in the AI community. There's these big data sets used for training models. Most of the data is coming from the Western world, from US, UK, and so on. So I think this is something which is definitely a problem, especially if in the medical field, if patient cohorts are maybe not representative when training one model and applying to another region. So I think explainable AI can be at least a tool to identify the problems, to really understand better what features have been learned, how are they used in the decision process, and then you need also some kind of ways to augment your data sets and to validate. You need procedures to benchmark and validate your AI models, whether it's kind of trustworthy to use them in these other regions or not. So I think here I definitely agree with you. This is a big topic and we are way behind here.
In many cases, as Kseniia said, the case of synthetic data. So like how can we augment and make new data sets? And early deep learning classes, you have those dogs and cats classification, and you have less dogs than cats. So you kind of rotate and zoom in and zoom out. But then it sort of keeps you under this small subset of features that actually matter. So as we're saying, we're sort of solidifying the biases which are seen in the pictures of these people who has been seen. One of my favorite projects is the project from MIT regarding the face recognition and how different people and different genders of color and people who are Caucasian are seen as more recognizable or less recognizable by the algorithms which are standard of the big companies, as also Wojciech has said that you've researched some of these, that there was a watermark and it means it's a horse. And we can see that the amount of data that we have from people who was on the front lines of all the pictures back, in the 90s, then in the 2000s. So we see that these sort of biases are there, and the explainability topic that we hear about is one thing, but the other is, and it's, I think, a big topic for another panel, hopefully next year, what we can do with the data to have the data more equitably distributed and equitably sourced.
Yeah, and I think we can also learn from other fields in that. I think epidemiologists, this is kind of a daily problem for them to be aware that there may be missing data, there may be some effects that are not captured in the data. And I think in the field of AI, we are sometimes maybe too naive. We're just taking the data and throw it at our models without really caring about the quality. And I think other fields are more developed.
By the way, I can't do that. I will be in jail. So, sorry. So, but I think other fields, but definitely, from Allegro point of view, which is e-commerce market, I can't do that. I have to be very careful with the data. And in fact, actually, another real world example is, from a bias point of view in the data, if people are trying to get a loan, and I have tons and tons of data on older people who are older, which then biases younger people who are trying to get it. So how we solve this is we make sure, again, when I talked about those 20,000 data points, how do I make this fair? But I can't just throw data in. And again, I didn't mention at the beginning when I should have, but really, again, we have to really have humans, a human curated set that also helps us to make sure that we get rid of these biases. Sorry, went a little bit off track.
Yeah, just a quick one on that one. Just a question again. So recently, Dario Amadei said on the podcast with Lex Friedman that soon we won't have enough data because we just to train large language models because we basically we grabbed already all the data existing from the internet. So is it a big issue especially in explainable AI? Like, Do you agree with?
Oh, that we'll run out of data?
Yes.
I mean, I heard these kind of claims. I think we need to really care about data quality, and maybe we should work with the data which we have, but try to improve its quality. And I think explanations or explainable AI, at least the methods we are working with, can be seen as a lens. So these methods tell us like how the data looks like from the model's perspective. So it's like a model lens on the data. And I think this can be very helpful to understand what's in the data, maybe what is not in the data. So we need systematic methods which help us to get more quality on the data. And then I think we can maybe train better and more trustworthy models.
Yeah. My answer is no, by the way.
Yeah.
We won't run out of data.
But the question is it good or bad? Because having all the data is actually good because you don't need to look for more. Yeah, you have everything already, so you can create the best model possible. So, I think it's up to, the question what you are going to do with the data. And with the bias, I guess that the problem is that models are making mistakes, and they are making mistakes for a different amount of mistakes for different groups. Having perfect models, it's not a problem, because then who cares? We have good decisions, best decisions, no mistakes. So it might be that having all the data is actually a good thing.
Yeah, it'll never happen. Listen, sorry, I'm just going to bring some reality, right? So quickly, you have wearables are coming more and more popular. You have IoT devices. The data collection is going to just continue. It's going to expand. It's going to be, almost like Moore's law, right? And as we continue to, advance into other technologies and space, the more and more data. The data collection is just going to continue. In fact, actually, companies like AWS, Google, et cetera, they're going to love it, right? Because where are you going to put that data, right? I'm already running into problems because I also have GPU problems eventually, right? How am I going to pay for this? How am I going to pay for the electricity, right? So, by the way, data is never going to end, and I can't ever fathom in my mind of when it would ever stop. Because as new technologies come, generation comes, or it's just going to continue to develop. So sorry,
I guess that he was referring to text data, like poems, fiction, things like that. So
People
this
stopped
might
writing.
be.
I don't think it'll happen.
Let's talk about it next year.
Yeah.
Perfect. We have a plan. So I think it's interesting. There is this thing about the model collapse, right? That when we train LLMs in this perspective on the generated LLM data, then they collapse. So they try to talk about things that are not even hallucinations, that are just bizarre things that don't make any sense. Even for us humans, for us, a lot of things make sense. But I wanted to ask you sort of like, it's an open question. So we talked about what is important to combat bias. We talked that explainability is one thing, but then we have this whole perspective of things that we need to do, taking care about the model, getting the data, using the data correctly, and training them. So what is the next thing when it comes to bias? Do you see anything else that we can do that we haven't mentioned to fight bias in AI? We have mentioned it all. Okay.
I don't think so. I think that it's just as the problems come up, then we start working on more of the solutions. Just again, my un-PhD comment is really how do humans work? How do we function, especially from a business e-commerce point of view? Where am I heading? And then what are the problem sets that I need to take care of? It's harder. I can think from a vision point of view 3 to 5 years in advance on products, which is my job, but understanding, okay, are some biases being interjected, or are there other ways to remove this bias? It becomes difficult. Again, this is why I mentioned a couple times, I really think the bigger problem, if I was to look in the future, which again part of my job, is the neural networks. And I'm going to use an old term, sorry, because I'm old, positronic brain type of concept, right? For those that read Isaac Asimov. But really, as AI becomes more and more complex, it becomes more and more difficult for us to figure out the bias. And this is where the tools, we really we need more and more advanced tools to figure this out. So, and we have some of those tools now. Again, you're the experts, but mapping, where in this neural network is the heat, in a sense, generated? Where was the most complexity being looked at from the model perspective? But so this is. It gets difficult, but I'll turn it over to the experts.
I think there may be also some self-correcting mechanisms which can kick off at some points. Because, I mean, if we train a model which is specialized for recognizing horses, cats, and dogs, then maybe using a copyright tag is a valid strategy, because then you minimize your test error or your validation error. But if it comes to interacting in the world, like really having more complex tasks and multiple tasks, as we see with LLMs, that they can not only like answer questions, but they can summarize text, they can translate text, they can a lot of different things at once, then I think the representation, which is kind of learned internally by the model, automatically matches the true distribution of the data. So I hope that the more we let the model interact with the world, the more it will kind of self-correct, because it needs to learn the true thing in order to solve this multitude of tasks. So it cannot just rely on the copyright tag.
So to add to this true thing, I guess that there are two phrases that should appear in this panel, and one is the right reason. Actually, Wojciech is using this a lot. So maybe these models are working, but for a wrong reason. So in future, due to the data drift or model drift, they will stop working. And second is safety. I can imagine that the way why do we need XA is to make sure that these solutions are safe, and there will be no harm done in the future because of some changes in the data distribution.
Maybe to add on that one more high-level overview. Someone smart said, like, actually AI is not biased, humans are biased. And AI evolves very quickly, but humans don't change. And you can see it in conflicts, you can see in the way how women are treated in different countries, you can see like child labor and all this type of things. And it doesn't change. And so the question with this AI is actually also how it's used. Is if AI tool, which is potentially unbiased also with the great research, is it used for good reasons? Is it used for personalized education to improve workforce, to upskill the population? Or it's used to limit access to the credits for women in different countries? Again, if AI is used for healthcare, or it's used for military reasons. So I think the big gap is also about understanding what is AI, especially the educational perspective. And what we've been doing, we are actually launching it this week in Davos, the AI Skills Coalition. And this is like a global effort from ITU with many UN partners, but also private partners, to bring the AI trainings to the fields, for the government's officials to understand what is AI about, to the IT professionals in developing countries to actually upscale their knowledge about AI. Because if we have a better understanding of what's coming, what is AI, for the general public use, I think that would remove lots of biases in future.
I think this is we're getting into an important thing, which you said, Kseniia, that humans are biased. So how can our models not be? We need to make decisions. Where is the correct bias, the bias which basically lets us say if someone is sick or not? This is also a bias. And where is the unhealthy bias of we won't hire someone because they're a woman, for example? And I think we need to look into ourselves. When we look into our AI, these are both things that we still need to do. We need to explain AI's decisions, but our decisions as well. So only in this, let's say both things, when they happen, we will be sure that our AI, maybe in the future, will be for everyone, explainable, unbiased. And I want to thank you all for listening, and thank you our perfect panelists, Przemysław Biecek, Kseniia Fontaine, Wojciech Samek, and David Roberts. Thank you so much.